Now, the next thing is, as we saw in class, that we did these formulas. So let's write down kind of the shortcut version of them rather than the long version like I had on the PowerPoint in class, or if I wrote it out. And if this is Z formula, we're going to take the mean plus and minus Z times sigma over the square root of n. Okay? And so this is two values. X bar minus Z times sigma over the square root of n, and X bar plus Z times sigma over the square root of n. And this number, whatever we get here, we're going to round down. And this one we're going to round up. That's to maintain this percentage in the middle, that it maintains whatever confidence level we want. Alright, for this one, the formula is almost the same thing. It's X bar plus and minus, and instead of a Z, we use our T value. And then of course we won't know sigma, but we will know the standard deviation of the sample, and so we use S over the square root of n. Okay, so the difference, again, remember from before, sigma, standard deviation of the population, and S is the standard deviation of the sample. Okay, so that's really the difference between the two. Do I know the standard deviation of the population? Yes, then it's a Z interval, and we use that here, and we use the population given. If it's not, if we don't know the sigma, the standard deviation of the population, then we make a T interval, and notice that they're almost the same. The Z becomes a T, and the population standard deviation, we use the sample standard deviation. Okay, so that's how we're going to start out these problems. So let's try this first problem. Length of growing seasons. The growing season for a random sample of 35 U.S. cities were recorded, yielding a sample mean of 190.7 days and the population standard deviation of 54.2 days. Estimate for all U.S. cities the true mean of the growing season with 95% confidence. Alright, so let's go through this again. The sample mean is 190.7 days, and the population standard deviation is 54.2 days. Okay, and our confidence level is 95%. Okay, so that's where we start. So the first question, if we go back to our decision, do I know the standard deviation of the population? The answer is yes. It was right in the problem, and I labeled it with a sigma to indicate so. So that means I'm going to use the formula X bar plus and minus Z times sigma over the square root of n. So the only thing I've left off here is how many days, and if I go back to the problem, the growing season for a random sample of 35 cities. So n is 35. Alright, so now I just have to plug in my numbers, 190.7 plus and minus 54.2 over the square root of 35. And of course the last thing I need is the Z, so I get out the table. We have a 95% confidence. It's a Z, so I slide all the way to the bottom, and I find I get 1.96. So I plug that in my parentheses, get out the old calculator, and we have 190.7 minus 1.96 times 54.2 divided by the square root of 35, and I get 172. I don't write it down yet. I'm going to do the other one. So now everything stays the same except the minus. So all I have to do is go back up, highlight this, and then just go over and change the minus to a plus, hit enter. So I'm going to round the lower one down since my data was one decimal. Let's keep it that. So I have 172.7 less than mu, because that's the thing we're estimating. It's less than 208.7. And I have my confidence interval of the mean.